Right, object-oriented programming is a paradigm in computer programming. C# is an object-oriented programming language. Classes can serve as prototypes or templates for objects, where, for example, members of classes like properties and fields can be used to store and change the state of an object. Methods, for example, can be used to invoke object behaviors and in doing so change the state of the object. So a very simplistic example would be a car can be represented in code as a C# class. This class can contain a method named startEngine. The developer can create a new car object using the new keyword and call the startEngine method. Calling this method invokes many procedures that need to be run in order for a car engine to start, which then results in the car object state changing to engine started. So you could have a Boolean field or property member of this object that can be used to store the state for the object. Let's call this field or property engine started. If the startEngine method has been called, the engine started field or property could be set to true in order to store the appropriate state of the object. The main object-oriented principles are encapsulation, polymorphism, and inheritance. The principle of abstraction can also be included. We are going to focus on just one of these principles in this tutorial, namely encapsulation. What is encapsulation? Encapsulation is the practice of encapsulating data and functions into a single unit, a class for example. The need for encapsulation is to protect or prevent the code data from accidental corruption. This protection can be implemented through the use of access modifiers. The available access modifiers in C# are applied to types or members through the following keywords and keyword combinations. Public. If a type or member is public, it means the type or member can be accessed by any other code in the same assembly as where the type or member is declared, or by code in another assembly that references it. Private. If a type or member is private, the type or member can be accessed by code resident in the same class, but the member or type cannot be accessed by code external to the class in which the member or type is declared. Internal. If a type or member is internal, the type or member can be accessed by any code within the same assembly but cannot be accessed by code within another assembly. Protected. If a type or member is protected, the type or member can only be accessed by code within the class in which the member or type is declared, or by a class derived from the class in which the type or member is declared. Protected internal. If a type or member is protected internal, the type or member can be accessed by any code in the assembly in which it is declared, or from within a derived class in another assembly. Private protected. If a type or member is private protected, the type or member can be accessed only from within the assembly in which the type or member is declared, by code in the same class, or from within a type that is derived from the class in which the private protected member or type is declared. So the principle of abstraction is often confused with the principle of encapsulation. I would say the difference between the two concepts is that encapsulation is concerned with the protection against unintended access to data belonging to a class member or type. And I would say abstraction is a design principle used for abstracting an interface for an object in order to decouple design implementation from code logic implementation detail. So for example, a real-world function of starting the engine of a car. All a user needs to know in terms of starting an engine of a car is to turn the key in the ignition. So in code terms, you could have a car object that contains a method named turnIgnitionKey. Calling the turnIgnitionKey could set in motion many complex processes which are executed in sequence to start the car's engine, but all that needs to be exposed is the turnIgnitionKey abstraction. The complexity involved in starting the engine is abstracted. Knowing the detail of how the turnIgnitionKey method works is not necessary to start the engine of the car. An even more simple example is switching a light on and off. You don't need to know about circuits, electrons, voltage, amps, resistance to turn on a light. You only need to know how to operate the light switch. In In C#, abstract classes and interfaces can be used to implement this design principle. I won't go into too much detail regarding the principles of inheritance and polymorphism, because these principles will be explored individually in detail in upcoming tutorials. Very basically, the principle of inheritance allows for a class to be based on another class. The class based on another class is known as a derived class. The class on which the other class is based can be referred to as the base class. In C#, an abstract class is a class that cannot be instantiated directly. The principle of polymorphism is the provision of a single interface to entities of different types. The word polymorphism has Greek roots, poly meaning many, and morph meaning form. A polymorphic object can take on many forms, but this principle will be explained in detail in an upcoming tutorial. Please give this tutorial a thumbs up if you feel you've gained value from viewing it. Please subscribe, it's free and can help you reach the next level in programming and technology. And please smash the bell icon to be notified of future valuable content, which will be coming soon. Please feel free to engage with me in the comments section. Thank you and take care.